Wow, what an amazing place to be at. This is really, really cool. I'm very happy to be here, and I'm very happy that I get to speak about the topic that I'm very passionate about, and that is testing. I promised I would tell the story about how I got into testing. And while I was studying at this Royal Institute of Technology in Stockholm, I had done a bit of HTML before. This was sort of, I remember in '96 when I learned to do frames, and I was really proud. Then I learned that I shouldn't do frames, I should do tables instead, and then stuff got weird. But some of my friends had programmed before, so they were at university and they already knew how to program. And they were saying that testing is really boring. I would never, ever want to get a job as a tester. And for some reason, that sort of sparked my interest. And I thought, well, this is sounds like kind of important. Can it really be that boring? So during a school project, when we were done with all of the programming tasks, I set aside some time and I did some testing tasks as well. And I had a blast. It was really a lot of fun. I was sitting there and I saw some bug and I had to try to reproduce how I actually managed to get there to begin with, and then I had to try to find the reason for it to be there, and I felt like a detective. I really loved it. And this was about 10 years ago, and I've been testing ever since. So my theory is that the things that I know about testing, all of the skills that I have and the things that I know, are going to be helpful to you as programmers. And there is a reason for this, and that is because there is one simple piece of truth about quality. And that is that you don't test quality in, you need to build it in. What I mean is, it doesn't matter how much testing you do on a product. It's not going to make the product any better. If what you have is a ball of spaghetti code, it doesn't matter how many tests you run on it, it will still be a ball of spaghetti code. You can't make quality magically appear in a product by doing testing. The only thing that testing can do is to reveal the flaws that you have in your product. So when people say that testers, they break stuff, that's not true. Testers will find where the stuff is broken. Let me show you. Here is your spaghetti code. If you add some testing, what will you get? You will still have your spaghetti code, and you will have 165 bug reports in Jira. Now, if you're a user of your software, does it help me to know that there are 165 bug reports in Jira? No, I don't care. It doesn't matter to me because my experience of using your product is going to be the same, whether or not you have your bug reports or not. Now, these can be very valuable as information. You can act upon these bug reports and do things to your software which will make it better for your user. But you can't really just have this information and you're not very much happier from it. So the information in itself is useless. The things that you do with it is important. So this means that you should think about quality while you're developing. You shouldn't see quality as something that you can just sort of add afterwards. This is something that you need to incorporate into your work. And in a similar way, there is no testing phase. Testing isn't a phase. Testing is a part of development, and testing happens all the time during development. So the earlier you start thinking about testing, you start talking about testing, you start thinking about what scenarios are there, what are the possible problems in my software, the easier it will be for you to incorporate all of this knowledge into your designs, into your architecture. Now, since testing is a part of development, in order to be good at development, you need to be good at testing. And all the programmers that I know that are excellent, that are really good at what they do, they also understand testing. Well, you need to really understand what it is. You don't have to be experts at testing, because that's my job. But at least you need to understand what it does. What is testing? What isn't testing? What does it depend upon? What does it do? There is a myth in the testing community, and I've also heard programmers talk about it as well. And that is that programmers can't test their own code. Have you heard this myth? Have you talked about it? And this is simply not true. Now, I can understand if it's probably a tester who came up with this, who wanted to sort of feel proud of their job and have a job security and feel that I'm important, the things that I do matters. Because the programmers, they can't test. I can test. I'm the one who makes sure that this product can be used. And somehow, and very unfortunately, programmers started believing that this was true. So what people say is, programmers, they can't test their own code. They can only see the happy path. They can't see that there's problems out there. It's only the happy path. Or they will say, programmers, they can't test their own code because once you started programming stuff, then you can only see that way, and you can't look around and see that there are other things as well. Well, there is a difference between things, and I want to talk about two scenarios. In one case, you could code your happy path, and then you ship your code off to a QA department, and you say, if there's any problems with it, they will find it. Or, in the second scenario, you can code your happy path, but you will know that there are other things as well, that there could be problems ahead, and that you need to investigate those later. Can you see the difference here between those two scenarios? There's a difference in responsibility as well. In one case, it's the QA department's responsibility to make sure that there's quality in your code. And in the other case, it's your own responsibility to make sure that there's quality. And I liked how Sally approached this yesterday as well, when she talked about ethics and your responsibility towards design. And she made me think of a scenario where you have a product owner who comes into a room and asks the team, I want this feature done. How long does it take? So you can either tell the product owner, well, if we do a hack, we squeeze it in and we put it in the wrong layer, it should really be here, but instead we put it there, and it's going to be really ugly. We can do it in a couple of hours. Or on the other hand, we can do it the way we like. We can do proper testing, and we can implement the patterns that we think are good, and it's going to take us a couple of days. The product owner will probably pick the first solution. Why not? But why would you even propose that solution when you know in your heart that the mess that you create by doing the short-term solution is going to come haunting later on? You will be there the next time the product owner comes in, and you won't be able to solve it in a day because you'll have to take 3 days because of this hack that you did earlier. So take some responsibility for quality. But let me ask you this. How do you work when you're programming? I would guess that you would sort of write a bit of code, try it out, write some more code, try that one out, and so on. Is that how you work? Yeah? Well, you know what? You're already testing, because that is what testing is. It's investigating, it's trying out things, seeing if this is working or not. So I believe that the people in the testing community who say that programmers, they can't test their own code, they don't really give you enough credit. You're smart, competent people. Of course you can test your own code. Now, I also remember a situation when I sort of saved someone's ass, because this is sort of what you expect testers to be doing. And this guy sent me an email, and he said, OK, I'm ready with this feature. It's ready for test. And I decided to try it out, and I met with a blank screen and then a stack trace in the console. It doesn't even start. Now, first I'm really angry because this is such a waste of my time. This guy hasn't even tried it out for himself yet. But also, if we had just had a bit of a discussion about this before, I could have easily said that the first test I'm going to do is to try to start it on this computer. And we would have known that we had to do something to make it work on that computer as well. Not just the developer's computer. No, it works on my machine. I guess you heard that. So as testers, my job as a tester, I feel like it's not my job to save your ass. It's my job to help my team see what risks are there out there, what problems could there be, to help them to identify those things and incorporate them into their work. So to summarize, I would like you to know that you have to build quality in. And I would like you to learn about testing to be better at development. So let's move on towards talking about testing then. And there is one important thing that you need to know about testing, and that is the difference between tests and checks. And I would like to illustrate this with an example. Let's say that we have this calculator. What kind of tests would you do on this? If someone says to you, can we release this calculator tomorrow? Please test it for me. What kind of things would you do with it? Type in it? Yeah? So, addition. Parenthesis order here. Excellent things. What more? What did you say? Does it get pi right? Good question. Resizing the font. Interesting. Yeah, we're getting somewhere. What did you say? 0 by divide by 0. Yes. What would you get then? You would like to see, do I get a good error message, or what? Do I understand what I did wrong? So these are all excellent tests. You would probably try to go through all of the different kind of operations that you can do. Perhaps you would also open up a lot of calculators and see, is there a common resource which is being used by these calculators? Or resize them, or enter text into the input field, or just keep pressing the key, like take it to your kid and have the baby press the key 1,000 times. Now, some of these tests that you suggested, we could automate. We could automate the subtraction and the addition and things like that. Division by 0 we could also automate. Does a calculator actually do this? What do these tests have in common? They are tests which have a correct answer, a single answer. Does 2 plus 4 equal 6? Yes or no? No one is going to be like, well, you know, it depends. If it's a good day. JavaScript does, someone said in front. Well, these are the tests that you will know. Is it correct or is it not? And these kind of tests we like to call checks. Checks are predictable. Checks are objective. There is one answer. They're discrete. It's yes or no, nothing else. And you use these tests to verify things. And these are the kind of things that you'll find in your unit tests, your Selenium tests, your BDD scenarios. They can answer yes or no. They can check stuff. You can imagine someone with a clipboard going, 6 plus 2, 8. Yes, check. Now, there are other kind of tests. So if you look at the calculator, we talked about resizing the text. What would it look like then? If I increase the font size, would it still be able to fit? Would it look okay? If I do a division by 0 and I get an error message, is that something that is meaningful to me as a user? Do I understand what I did wrong? Or is it general error and I have no idea? And these are the kind of tests where you need to be a human to understand. You can't ask a computer if it's right or wrong, because it sort of depends. You can be opinionated about this. You can say, are you crazy? That's the wrong kind of error message for division by 0. Or, no, it's completely normal. It's a general error. You did something generally wrong. So you need a human. You need sapiens to do these kind of things. And this is what we like to talk about as exploration. We don't have an expected answer when we talk about exploration. We don't really, it depends, it's in the eye of the beholder whether this is right or wrong. Is this loading too slowly? Can you really put a value on that? You can probably do some research and think that in general this is loading too slowly. If I click a button and it doesn't appear to do any work, and someone says maybe we should add a spinner so that the user can see that it's doing work. Those kind of things isn't something that a computer can come up with. So we use these things to learn about the system, to investigate. We can also do models of the system. We could, before we started testing, we could have sat down all together and we could have started drawing a model of how does this calculator work? Does it have any dependencies to anything else? Or what kind of components are there to do this? And that would also be in testing, because then we could have found some sort of flaw in it. Wait a minute. this connection doesn't seem to be right. This is not what I meant when I talked about this. So on one side, we have the checks. We have the things that are that have one single answer. And on the other side, we have the exploration, the things that we use to sort of see if this is good enough for us in our subjective view of things. And why does this matter? Why do I bring this up? It's the source of a lot of misunderstandings. Because when I ask someone, have you tested this? And they say, yeah, sure, I have. Well, what kind of test did you do? I've written 2 unit tests for it. For me, that's not tested. For me, that's, okay, that's good. You have some checks. That's okay. Have you tried launching the application? No. Then you haven't really tested it. And I put a link down here to an article which talks about testing versus checking in more length, which is interesting to read. It's by James Bach and Michael Bolton. Not the singer Michael Bolton, but the tester Michael Bolton. Not the guy from Office Space either, just Michael Bolton, yeah, the tester. But I think that Elisabeth Henriksen sums it up very well, and Elisabeth Henriksen is a marvelous tester. And she says that for anything to be tested, it has to be checked and explored. Doing either one of these by itself is not enough. Now, checking is going to be a part of exploration because you're probably going to enter numbers in the calculator and know if it's right or wrong. But you can't have it sort of one or the other in that sense. So testing is going to be checked plus explored. And this is important to remember. So I want you to remember that just writing some unit tests is not enough. You need to launch it, and you need to do some other things to it as well. So now I want to show you a movie. And I want you to look at this movie in silence. And even if you sort of recognize what kind of movie this is, I want you to be quiet and follow the instructions, because it's going to be much more fun this way. Okay? Can you do that? Good. Let's see if I can launch the movie. If I can do my part of the job. I can actually put some sound on this, I think. Oh. Doesn't matter. Sorry. To get back to this one. There we go. Okay, we should start counting instead. So the sound doesn't really matter, actually. It's just for the, what do you call it, ambiance.
How many passes does the team in white
awesome.
make?
Go!
The answer is 13.
Anyone get it right?
But
Awesome.
did you see the moonwalking bear?
Go!
So this is an ad done by the London Transportation Department or something like that, to make sure that people are actually looking out for cyclists, because if you don't really know that they're there, you're not going to see them. But how does this relate to testing? Why am I showing you this film? It's got a moonwalking bear. I don't need a reason. Well, I'm really happy that I can sort of fit in a moonwalking bear into my talk, but there is a reason as well. I think that this really illustrates very well what testing means and what testing can be. It can be that the bug would be the moonwalking bear, the thing that you're not really looking out for. And often I believe that when we work in teams and we work, especially work in Agile, we can be so focused on getting this feature out. We sort of start missing things that should be visible to us. And those can be the bugs. So what you want to do in testing is that you want to make sure that you make a point to be looking out for bears. That you want to make sure that you don't really do the one thing that you always do. You do different things. And if you do different things, you might be able to catch these bears. Also, we could have probably automated this. We could have done some tests to make sure that we count all the passes, and then we make sure that the answer is 13, and everything is fine. And we would probably be following the specs. I guess the product owner would be like, well, I want to know how many passes there are. But where in the spec did it say that there shouldn't be a bear? These are the kind of things that probably aren't in your specs. You get a list of things that need to be done, and you get a set of rules, or perhaps you don't get a set of rules you need to figure out by yourself. But there are going to be these unexpected things that you didn't think of when you wrote the spec. And you can't ask people to write perfect specs. It doesn't happen. And there's no point in trying to do that. So that's why you need the testing, to see, is there anything unexpected that we didn't think of? What would happen if we do this? So I would like you to... My clicker stopped working. Yes, good. I would like you to try to find the moonwalking bears that are in your software. And I believe that testing is a good way to do this. So now I would like to go in a bit more regarding techniques, real things that are concrete that you can do about this. But there is one sort of guideline, and that is to be different. Try different things all the time. Try different kind of personas when you do stuff. Try to be someone else. Try to be in a different location when you're testing stuff. Try different languages. Try different time zones. Try changing the time on your machine. Try different kind of character sets. Try a lot of different things. And specifically, if you have an application that you're very familiar with, you probably have the same paths with you navigate through. You just click the menu, you click this, you click this, you click this, and then you get to that view. But there's probably another way to get there. There might be a keyboard shortcut for it. You should try that sometime. Or another time, you do it in a completely different way. And by doing all of these things, you will create your own luck in a way. You will stumble upon a bug and you will say, whoa, I was lucky to find that one. But you weren't lucky. You were being skillful. I had one of these experiences once when I found a bug just the day before release. And I went to the programmer and said, whoa, it's a good thing that I found this the day before release, now we can fix it. I was so lucky. But as I was saying this, I realized this wasn't luck. It's because every single time I went through this part of the application, I did it in a different way. And this time I ended up stumbling upon the bug. So it wasn't that I was lucky. Well, maybe I was lucky, but I created my own luck anyway. Now, the first technique I want to show you is the mind map. Mind maps are an excellent way to explore functionality together. And by doing the drawing of things, you are creative. So you increase the likelihood of you thinking of new things that could be problems. And this is something a technique to use before you actually start working on a feature. So bring your teammates into the room, bring your product owner or stakeholder or anyone that can have an interesting input, and start talking about the feature that you're going to build, and start talking about what potential problems could there be, what different scenarios are there. So here is my team's mind map right now. We have it in our office next to our workstations. So every one of us can sort of look up and see the mind map. You don't really have to go anywhere. You just lift your eyes and you will see the mind map. And this is a mind map which shows, I'm going to show the details of the map later, which shows us what kind of scenarios are there. Have we covered everything? I put some sort of post-its here for the things that are automated so that we can see what kind of coverage do we have right now with our automation. And this is what it sort of looks like. Is it possible to read in the back? No? Yes? No. Right. So in the middle of the mind map, we have the name of the feature. And then we have, this is a flow, so we have the different steps in the flow. We have the first step, second, third, fourth. And then we have a little bonus thing here, which is the customer types that we can have, and sort of a general thing, that sort of stuff that didn't fit anywhere or that applies to everything. So for example, our second step is to enter personal information. This can be a social security number, an address, a telephone. And for example, with the social security number, it could be invalid, or it could be that you're under 18 and then you're not allowed to use this. So we try to think of what are the different things about personal details that are important to us, and what can happen with these things. We also have, for a phone number, we have an example here of what an invalid phone number could be. We also realized that we would have to do some field validation on this, with sort of weird characters and maybe large data. So these are a bunch of ideas that we had when we were in this room together and tried to figure out what kind of complexity is there. We also have a very important part, which is the customer type up here. So we can either be a new customer or an existing customer. An existing customer could be an online customer or not an online customer, which could have a payment method registered or no payment method registered. And sometime when we were doing all this, wait a minute, I don't really understand. So you can be online, but you can't have a payment. What if you're just an online customer? This was an excellent way for us to sort of map out all of this complexity. And someone just came up with it, but what about if you have a gift card? And we hadn't thought about that before. So that was amazing to see that someone just would come up with this. I have also put in some checks for automation there just to show you how much there is. So why do I want you to do mind maps? How do you catch a bear with a mind map? Well, if you use these mind maps together, you will be able to draw on everyone's perspectives. Every team member in the room has their own specialty, their own worries about things. Someone is worried about the database, and we'll bring up database stuff. And someone knows a lot about languages, and we'll talk about that. The product owner is very concerned about payment methods, naturally. So all of these different perspectives are brought together, and together you will create this image of what is it that we want to do, and you will get a common understanding about it. And by putting this mind map next to our workplace, we also managed to, when someone came up, wait a minute, we forgot about the receipt thing. They were just able to go up to the mind map and add it there, and then everyone knew that there was a receipt thing as well. We had forgotten about that. I guess otherwise we'd try to send an email or something. I'm not sure. If you think that this is a bit too intimidating to just come up, everyone, let's do a mind map together, and they're going to think you're crazy, start by doing it by yourself. It's better than nothing. Or maybe just grab someone else and sit in a pair and do it together. You can also start by making lists, and then the list points will start having arrows to each other, and then you'll have a mind map at the end of it. Yes, I'm really focused on the map part of it, because I believe it's very important for the creative part and for actually remembering things and retaining information. Next technique is San Francisco Depot. San Francisco Depot is a heuristic, and I'm going to read it here. Let's see. A heuristic refers to experience-based techniques for problem-solving, learning, and discovery that find a solution which is not guaranteed to be optimal, but good enough for a given set of goals. In short, it's a rule of thumb. So it's an idea that, in general, if you have this kind of problem, then you should apply these kind of things to solve it. And this is a heuristic for testing. It is also a mnemonic, which means that it's a rule to remember things easily. So we take some of the letters in the name and we make a word out of it. That's how we remember it, is San Francisco Depot. And the letters will stand for things. And here they are. We have structure, which is what is the product in this case. Function, what it does. Data, what it processes. Platform, what it depends upon. Operations, how will it be used? Time, how is it affected by time? I'm going to give some examples of each of these categories. But if you want to do an exercise in your head, try to think about one feature that you're working on or something, and try to see how does this apply to the feature that I'm working on right now. So structure, what is it made of? This could be the files of the program. Does it have a log file? Does it have configuration files? What does it have? What kind of physical things? Well, they're not really physical, they're electrons, but sort of what physical things does it have? Does it have a connection to a database? Is it a single model application, or are there several models that are talking to each other? For function, it's more of what it does. What kind of error handling does it have? What kind of tasks can you do with this thing? Data is what it processes. And this could be the data that is inputted by a user. It could be the data that it receives from another system. And here is the place where you sort of think of all the classic input stuff, tests that you do when you have weird characters, you have long strings, you have big numbers, you have negative numbers, you have all of those kind of input-y things, tests that you do. It can also be what kind of dates does it have? Is it in the right format? Do we get it in a JSON format? Do we get it in XML? What can happen with this? And then we have platform. What does it depend upon? Are there any other components which this has to communicate with? Any third-party applications? What kind of device will you run it on? Will you run it on Windows? Will you run it on Unix? What does it run on? Does it need an internet connection to work? And then operations. How will it be used? And here are all the things that the user will do with it. Who will be the user of this? If it's the calculator, would it be an old lady in the store trying to make up how much the groceries are going to be? Or is it a mathematician? Who will be the user of this? And what will that person do with it? So this is typically the part, in my experience, which has the most things in it. And then time. How is it affected by time? And this could be sort of time stuff, as in time zones, or if I use this around midnight, is that a problem or not? But it can also be the speed in the sense of if I do this quickly or slowly or something. So the point of the San Francisco Depot mnemonic is to sort of trigger your imagination and to make sure that you haven't forgotten any of these perspectives. So each of these light blue boxes is a perspective that could be important for your software. And since this is a rule of thumb and not a general rule, some of these things will be really important to you in your application. For example, some will be really hard on structure. This is an application which takes files from one place and puts it in another, something like that. Structure will be really important. In other cases, structure is like, well, yeah, it's a web page, it's run somewhere, and we don't really care. So these will depend upon what kind of application you have. What you can do, and this is the advanced course, is to actually create your own mnemonic heuristic thing. Think about what perspectives are important for my application. What kind of things do I need to look upon to be able to see that I've covered everything in my application? And then you can do this kind of mnemonic of it. I have one team who did it, and they came up with the mnemonic success, and I think that the U was for usability or something like that. I don't remember the others. So that's something you can do. Next up, we have focus. And the thing that I see when people are new to testing is that they go all over the place. They try something here, they try something there, they try something a bit here and there, and then enter a big number, and then they go on somewhere else. So focus is really important. When you have done one of these mind maps, perhaps, pick one of the nodes and go into depth into this node. Go for, I'm going to test everything that is data related, and I'm going to do this for half an hour. If you've heard of the Pomodoro technique, this is excellent for this. Do 25 minutes of in-depth testing of input data. Or do 25 minutes of security testing for a while. By doing it more focused, you will make sure that you don't just split your attention everywhere. And you will make sure that you think of, have I thought about everything that is important for this part of the application? If you do find something that is interesting, you sort of find, oh, that I would like to look at that. Just make a note of it and come back to it later. Post it up on the Scrum wall or something. Next we have Randomize. And I'm not sure how many Mr. Test at Test Street 123 in the Testsville there are in the world, but I'm pretty sure there's probably a lot of them. And by doing the same data all over again, is that going to help you find any bears? So you need to randomize your data. And since you're programmers, you can do tools for this. For example, I'm using a tool now that my programmers have done, which is a social security number generator, which means that I'm using a new social security number each time I try to do tests. So you can do that. You can randomize your data and try to find tools or things that will sort of input new, fresh data into your system, and make sure that you sort of have the possibility to find new things, new kind of bugs. And then we have the checklist. When you think that you're done, you're like, I've tested everything. You pull up this checklist by Elizabeth Hendrickson, and you go through the things that she has there, because she has made a collection of all of the things that she knows about testing and the things that she tries when she does things. So for example, you have input strings. You have all of these kind of strings that you can try out. So are you done yet? Well, perhaps not really. I think there's a am I done testing list as well. If you Google for that, I think you'll find a couple of pages of these kind of things. I have this one laminated by my desk so that I can pull it up and look at it and say, okay, oh, I forgot about this kind of strings. You can also do checklists which are important for your application. It is very important for us to not forget to switch languages because we have users in another language and it needs to work. Because it can actually crash when you change languages. I've seen that happen. So you can do your own checklist as well. So to summarize this, it is important to know that you need to build quality in. It's something that you need to take as your responsibility to make sure that the products that you develop and the applications that you develop have a good quality. You can take your tester as a help for this, but in the end, it's sort of your code, so it's your responsibility. But share it with the team as well. It's important to know as well that tested is both checked and explored. Just doing the checks isn't enough. You need to do the exploration as well. And be different and do different things and try to see different perspectives. That way you will be able to find the bears. I hope that my tips today are going to be helpful to you. And that will get you on your way to even more brilliant software. Thank you.